A lot of students seem to get a little bit twitchy when they hear the word fractions. I suppose a lot of non-students get the same way. So if you're one of those people, this very short video is aimed at you. The topic of the video is equivalent fractions. What I want to do is I want to just show you some examples of equivalent fractions. And when I show you the examples, I'm going to show them to you sort of two ways. One of them is going to be the classic way where we list a bunch of fractions next to each other side by side, and then we put equal signs between them, and that's a good example of equivalent fractions. You know, science has shown that our brains really like pictures, and sometimes they can really be helpful ways to help us understand things. So in this really low-key video, I'm just going to show you some examples, and hopefully it'll maybe help you a little bit, or at least get you a little less twitchy. All right, so the picture that I'm going to show you is you can see it here, and what I've done is this is a block. This is one whole, I don't know what this is, but it's one whole thing, right? One whole rectangle. And then underneath that you see rows, and each row is that big rectangle is cut up into smaller pieces. And as you can see, going from top to bottom, the number of pieces gets larger and larger, and then of course each piece gets smaller and smaller. So I'm just going to try to show you some equivalent fractions. Sit back, relax, take a look at them, and maybe this will help. All right, so this is showing you. We can see in the upper right up here. We show this is the classic list of equivalent fractions. 1/2 is equal to 2/4, 3/6, 4/8, 5/10, 6/12. Right? They're all equivalent fractions. And then if you look at the picture, you can hopefully see why they're equivalent, because all of them, they all cover up the same amount of the overall rectangle. Right? They all cover halfway across. So just an example to show you. Right in the upper right again is the classic way, and then just pictures. I just want you to sit back and take a look at the pictures. Let's do another one. All right, so this is 1/3. 1/3 is equivalent to 2/6, is equivalent to 3/9, is equivalent to 4/12. And again, here's a third, right? They all cover, what makes them equivalent is that they all cover the same amount. The difference is that the pieces are of various sizes, and as the number of pieces gets larger, the pieces get smaller. I guess I'd be remiss if I didn't say, if you look at in the upper right hand corner here, when these equivalent fractions, you can sort of see the pattern here, right? You start with a third, and if you double the top and the bottom, you get 2/6, and if you triple the top and the bottom, you get 3/9. So each of those is a multiple of that original fraction. And one of the key things you have to notice is that when we double or triple that initial fraction, we have to double the top number and the bottom, both the same. Going the other way, when we have to reduce a fraction, right? If I started with 3/9, right? I'm trying to think of a number that goes into both of those. Well, 3 goes into both the numbers. So 3/9 is equivalent to 1/3. So that's how we reduce fractions. 4/12, right? And 2/6. You can see half of 4/12 is 2/6. So again, the point being, whether we multiply or divide a fraction to get an equivalent fraction, we have to make sure we do the top and bottom by the same number. All right, another one. Again, 1/4 is the equivalent to 2/8, 3/12. Here we go again, 1/4 of the whole thing. It's all taking up the same amount of space. It just takes more pieces the smaller the pieces are. All right, last one. All right, 1/6 is the same as 2/12. And again, nothing particularly interesting here. I just want to stick a picture in your head, hopefully, so when you see this sort of thing, that you'll have some sense of what we're talking about here using the picture, right? Anyway, hope it helps. If you're twitchy, hope this is a little help get a little less twitchy. But these are just pictures of equivalent fractions. Done.